So I'm going to tell you about some introductory chemistry concepts, including valency, covalent bonds, and electronegativity. So starting off with valency, each atom is made up of protons, neutrons, and electrons. Protons and neutrons are in the core of the atom. So in the left image of the carbon atom, you have the core, so the gray and the red circles, which is the proton and the neutron. And then around it, you have orbiting the electrons. And so, for example, in the carbon atom, you have several different orbits. Uh, the inner orbit and the outer orbit. In a hydrogen atom, you only have one orbit, and there's only one electron that circles the core of the atom. So the number of electrons that are in the outermost orbit of the atom is called the valency. So for hydrogen, the valency is 1. For carbon, the valency is 4. Now looking at this chart for other atoms like nitrogen, the valency is 3. Oxygen, the valency is 2. Fluorine, the valency is 1. And carbon, which is one of the most, if not the most important atom in biomolecules, has a valency of 4. So what does that actually mean in practical terms when it comes to biomolecules and biology? Well, the valency of an atom is the number of covalent bonds that atom can form. So hydrogen forms 1 covalent bond, oxygen forms 2 covalent bonds, and carbon forms 4 covalent bonds. So moving forward, here's an illustration of what I just described. So we have on the left a carbon atom with a valency of 4, meaning in the outermost orbit there are 4 electrons. Hydrogen having a valency of 1, so 1 electron in the outermost orbit. And then you have a molecule here in the bottom consisting of 1 carbon and 4 hydrogens. So this is methane. And it has 4 hydrogens, so it's a carbon atom with 4 hydrogens covalently bonded to it. And each covalent bond illustrated here is composed of 2 electrons that are shared between the carbon and the hydrogen. So taking this concept, looking at other biomolecules, you have hydrogen chloride, where electrons are shared between a hydrogen and a chloride atom. You have water, where electrons are shared between an oxygen atom and 2 hydrogen atoms. Then you have ammonium, where 3 hydrogens are shared between, where electrons are shared between a hydrogen and a nitrogen, and 2 more hydrogen and a nitrogen. And then again, an image of methane, where electrons are shared between a carbon atom and a hydrogen atom 4 times. And so looking at a stick model of molecules, in the top right hand corner is another image of methane. And so here two electrons are represented by one solid line. So every time you're looking at a biomolecule and you see a line, what this means is that there are two electrons being shared between the two atoms that are connected by the line. So now moving on to the next concept, and so the next concept is electronegativity. So the electronegativity of an atom is the ability of an atom to attract to itself an electron pair shared with another atom in a chemical bond. So you can think of this as the gravity of an atom. So, for example, here looking at the periodic table of elements, as you move right and to the top, the elements become more electronegative, so they become what you can think of as heavier, or they have more gravity. So when you have electrons shared between two atoms, for example, between a hydrogen, which is here at the top left, and a chloride, which is near the top right, so hydrochloride, the electrons will be closer to the chloride atom because it's more electronegative. It pulls the electrons closer to it. It has more gravity, so it pulls the electrons closer to the chloride than the hydrogen atom is able to. So an illustration of this concept is here in hydrogen chloride, where two electrons are shared between a hydrogen and the chloride being more electronegative, so the chloride having more gravity pulls the electrons closer to it. And so this is represented by a cross and an arrow. So the arrow points towards the more electronegative atom. So in bromomethane, what is shown here further to the right, the bromide is the more electronegative, and so the arrow of the arrow and cross is pointed towards the bromine. So the electrons are closer to the bromine than they are to the carbon. When you have a more complex molecule, like the carbon the carbon that is bonded to 3 chlorides and 1 hydrogen, then what you have is an overall dipole. So overall, in this larger molecule, the electrons are being pulled in the direction of the chloride atoms. Another example of this is the ester molecule, where there are many atoms that contribute to the overall dipole of the molecule. So here the overall dipole is centered towards the oxygen and down away from the middle carbons. So why is this important? So this is important. This is important because when we are looking at interactions of different drugs with their receptors or their target enzymes, we can sort of approximate the similarities between different drug compounds. When you look at different drug compounds and that are in the same class, for example, different SSRIs, so selective serotonin reuptake inhibitors, many of them have similar structures, and so many of them bind similarly to their receptor because largely due to their dipole moment and the way that the gravity of some atoms pulls the electrons away from one end and towards the other end of an atom. So another concept that's important that is related to how electrons are distributed and electrons are pulled from one end of a biomolecule towards another are what are called aromatic compounds. And so these are 6 carbon compounds that allow for electrons to destabilize, or the electrons are not shared between 2 carbons. They are actually shared between all 6 carbons. And so these are special structures that are very hydrophobic and that are seen in biomolecules very frequently. So again, aromatic compounds, what's drawn here. So amino acids contain these 6 carbon compounds, and so they're hydrophobic, and they're involved in hydrophobic interactions, and so they're important for drugs and several types of classes of biomolecules. So that is it. That is all, and we are done.